Okay, I think we can start. It's the top of the hour, 1 o'clock. And so, welcome everybody to the LISP working group session for the people in the room and everybody that is online. I hope everybody is fine. um, the usual not well. You're supposed to read this during the registration process, the IETF. Um, some tips about this hybrid setup. So in person, you can log in the lightweight tool. Mitico tool is the small mobile phone icon that you have on the agenda. By that, you automatically sign the blue sheets. And if you wish, you can actually, if you are a presenter, decide to share the content, so your slides, and you can control the slides. Plan B is I share and you just say next. Okay, as for the good old times. Remote participants is the mythical setup we had in the last 2 years, basically. So you you see the video stream, the audio stream, the Jabber chat. Okay, as usual. For the questions, remote and here in the room, you queue up. So you raise your hand from the Mythico tool, and you, for the person here in the room, you go to the mic only when it's up to you to ask the question. We don't need to physically queue up. Okay.
And when you start speaking, please give your name.
Yeah, that's a point. uh, just a small reminder of the code of conduct, which is important here in the IETF, is about respecting everybody here in the room and online. To having personal discussion, always based on technical points, and know that everybody's ready to contribute here. Okay, so uh, I forgot. I'm Luigi. Joel is online. We are the co-chairs of the groups. Padma, our secretary, is also currently online remotely on the Mitico system. Here you have the usual pointers for everything, the charter, the Jabber room, stream, Mitico, agenda and slides. So here also the material, the slides that you are seeing right now. A quick update on the status that of our working group. So we have a few documents, 5 actually, that are already in the RFC editor queue, which is a good point. Okay, they are just a little bit stuck there because they have references to documents that are still in the pipeline. Actually, we have 5 that are in Alvaro's queue because they passed the working group last call. I mean, so they Alvaro needs some time to process not only our documents but all the working groups he's overseeing, right? And there is it's difficult to read, but the last document at the bottom is the Young model, which have been discussed, I think, last year, and I'm sure we are pretty close to the working group last call. So at some point this year, we may go for it, I would say. Okay. Um, today, the other working group documents are the LISP L2, L3 ID mobility. We will have a presentation today. The Young model, I just said, it will not be discussed today. There is a mistake in the slides. And then there are a few documents actually that are there, and we should try this year to discuss whether or not we want to move them forward. And so go for conclude the work and go for a working group last call, or check whether the working group is want to drop this work. We have a few tasks to be accomplished. I would say there is the not traversal document that should be done. There was an explicit request in the charter. We have it in the charter, so it would be good if we also focus on this one this year. The LISP DDT RFC, so 81111, we have a early allocation in that document, but the document is experimental, which means to make the allocation permanent, we need to move the document to the Lisp DDT on the standard track. So we have to think about have a 8111 bis in order to standardize also the DDT system. Okay.
What does it mean, allocation?
So there is the fact that in the IANA we have a Lisp packet type defined in this RFC. It is experimental, so could not be permanent because it's experimental. Now, to make it permanent, and the point is we are renewing this for the second time, which means the first time we just asked. First renewal was with the AD Alvaro that said that that's fine. Now we have AD and IESG that has to say it's okay. So we don't have so much time. So because I don't know how much we can continue asking to renew the allocation. Okay. So I think these are two main things we should try to accomplish this year. So the NAT and DDT bis, let's say. Okay. And as for the agenda today, the administrative is over. We have AID mobility. Alberto will present. Okay. Okay, Alberto Bis will present. So Fabio, so you will present the reliable transport. Okay. Then we have Bernard Heindel, if I pronounce correctly, which will present the crown-based Lisp. Okay. And then Sharon will give an update on the Lisp mobility routing. So unless there is anybody wants to do any agenda bashing, Fabio, you can come up. You want me to share? Okay.
All right. So this is a quick update about the EID mobility draft. Yeah, so this is the usual suspect of authors. There were a few comments that came up in the last IETF online, and we didn't have a chance to update the document yet, but you know, there was some work on layer 2 multi-homing that needs to be done to complete the last section in the document itself. I just have an update on the discussion that went in the mailing list, so we can go to the next slide. And basically, what this was raised at the last meeting, as I said, right? So the question is, how do we identify the layer 2 multi-homing groups? And the discussion and the problem is, you know, if there is a site that is multi-homed, how can you identify univocally the group when there are multiple airlock that are present in that site? So there was some discussion, should we use the site ID or should we go up for a new identifier at all? So next slide. And it seems that the conversation is going toward using a new identifier, the Ethernet segment ID. It's a 32-bit value that will identify uniquely the group of XDRs. The XDRs that are multi-homed, they get to register their ESID with the corresponding airlock, and in this way the mapping system can aggregate the multiple airlocks so that they all part of the same group. In this way, the two issues that you want to solve are individuate univocally who is the designated forwarder selected, and basically have a way that you can reconcile when there is a split horizon solution. In addition, in this way, Ethernet segment ID can also be associated to EIDs, not only to an lock. And in this way, you can deal with alliancing that allow for load balancing when multi-homing is active. And yeah, so this I think is the part that where progress was made. We will update the text to reflect this consideration here. And I think that's the last slide, or there is another one. Okay, the last slide.
And there is Dino in the queue for a question.
Hey, Dino. We miss you.
Hear me? This is Dino.
Hey.
Hi. Long time. You can hear me okay?
Yeah.
So I remember recalling that there was no reason not to use the site ID. Do you know why that has changed? And because now we have an issue, because what if the site ID is different than the ESID? Are the XTRs known to be in the same site or not? And the reason why at last IETF we talked about, or the IETF in the summer, we talked about using the site ID so we wouldn't have to change the packet formats. So do you know what came up to want to make that change?
Can I take that?
Yeah.
So this is Alberto.
Your name.
Yeah. So Dino, this is actually
Alberto.
reflecting the discussion on the mailing list where you said, and I think it's a good point, that an XTR may have different VLANs. So you may have different segments on the XTR, and then you may or may not want to put them in the same site ID, or like the same using a single site ID to cover all those different layer 2 segments. So we were kind of assimilating your point and trying to be coherent with the discussion on the list.
So that's what's confusing, because the slides say that it's an ESID for 2 XTRs, where it's actually an ESID per VLAN per pair of XTRs, or more than one. Is that true?
I guess maybe the slides were not specific. So I guess one way to put it is the ESID would be for layer 2 segment, which I guess you can say like per VLAN if you wish. Does it make sense now?
Yeah, maybe you should call it a VLAN a segment ID or something like that. And it needs to be clear. And these are put in registers. That's going to be a long list of. It could be a long list, right?
Yeah, but I mean, if they are different segments, they are different segments, right? I think,
Yeah.
I'm not sure.
So now the map register has to have up to 4,000 entries in it. So there's a lot of protocol machinery that has to be done.
So regarding the name, I may need to check. I believe that Ethernet segment ID is what other protocols use as well. But I'm fine if we want to call it here VLAN ID. Either way, I think at least for me, I don't know if someone else has an opinion.
Okay, it doesn't matter really what the name is.
Yeah.
That's just a moot point. But I'm worried about the scalability of this now. Can't we say that one or more XTRs are selected as a designated forwarder for all VLANs?
Like a default forward?
Because this is a big change of the map register, and I don't know if it's worth it for L2 overlays. That's the thing I'm worried about. There's a big cost here in designing this in for the benefit. So I'm making a judgment call. That's all.
Yeah, I don't have an answer for you, Dino. And actually, you are the multicast expert, so I would want and ask you. So the ESID is intended to address at least 3 problems, like designated forwarder, multicast, split horizon, and then the aliasing on the EIDs. So if you have a specific optimization for the designated forwarder case, we can certainly include that.
Yeah, what I'm suggesting is use site ID and you use designated forwarder election or selection for all VLANs. That's all. And you make that statement, and we don't have to change the packet formats.
I'm not entirely sure that we are back in the problem that we had originally, right? That you may have multiple VLANs in the same XDR.
Yeah, but I didn't suggest it's a all or one issue. That's how we could solve the problem. Because now you have to list each VLANs that are active. Well, you have to potentially have up to 4,000 entries in the map register, which makes the packet really large, right? And even if VLANs are not in use, if one gets configured at some point, you have to know who the designated forwarder is you have to do it before you configure the VLANs at the site, I think, or you're going to have a broadcast loop, right?
Yeah, regarding the number of VLANs, yeah, I don't have an answer. I mean, so can you have really, like, let's say, a registration where you would have all the VLANs configured at once? Because you usually send a registration which is EID to airlock, right? And then we need to add an identifier to map the airlocks, but also to map the ID for the aliasing case. So I don't
It doesn't
know if
matter.
you're gonna have that.
Albert, it doesn't matter if it's all. It could be 50, and that's still a lot, right? Because now you have to list everything.
But typically,
Unless
you don't
you
send.
use a 16-bit string,
No, I
and
understand. I understand what you're saying. I'm thinking from the kind of operation of the protocol that typically you send a single EID on the map register. Theoretically, you can send more, but typically you send just one EID, right, per map register message. So
yeah, but you might. I mean, no, you may want to pack them, right?
you may, but typically we don't do that. I don't remember now the text on the BIS documents. It may even say that it's not. Yeah, I don't want to code the test without having the RFC on top of me, in front of me, but
Yeah,
my
that's why I'm
understanding-
saying it's not worth it, because there's a lot more discussion that has to go in, like how you're going to do it.
So let's
So-
let's do this, Dino. Let's maybe for the next IETF, we between now and the next IETF, we can look at the scalability of the number of VLANs, and we can discuss in the next IETF how to handle that. Sounds good?
You
Sure.
can even start the discussion
No,
in
no,
the
we
mailing
do it in
list.
the mailing list. Yeah.
Yeah,
so
yeah.
that you have the
Let's
input
don't
of
wait till the-
everybody, so that we
Yeah,
reach
you don't wanna
next
wait till the next
IETF with a decision or
Do-
a solution.
Do you want to send Dino one note to the mailing list, and we use that to start the? Basically, what you're saying is that we should consider scalability because there are up to 4,000
VLANs, yeah.
entries per each EID, and EID can be grouped in registration. So
And the other problem is
even if they are
is
not
that there's one segment ID per map register, where if you're going to put multiple MAC address EIDs in the map register, then you have to have an ESID per EID, which means it has to go in the EID record, which means now you have to specify wherever an EID record is used in all the messages, you have to specify what the segment ID is. And for layer 3, you don't even need it. So you're going to end up using up the space inefficiently for layer 3.
Yeah, let's
That's
do
why
the
I think it
discussion.
should be all or nothing. You
Let's do the
select a
discussion to the-
designated forwarder for the site for all VLANs.
Yeah.
That's
So
what I think we
I
should
think that
do.
there are people that need to chime in that are US based and probably they cannot comment now. Let's do
Okay.
the discussion on the list, Dino, so they can chime
Okay.
in as well. At point taken.
Okay.
By the way, so if we end up with a map register that is too big, there is something that solves it that is called reliable transport. We're going to talk about that in a second. So
So we gather that you support reliable transport. We are stretching it a bit.
okay.
That's okay. I think we have an action, Dino. If you can post a note to the mailing list regarding scalability considerations, and we can take it from there. Sounds
Okay.
good, Dino?
Yep, sounds good. I'll do it.
Thank you.
Thanks, Dino. So the queue seems empty, so
All right.
Alberto, you can come up.
So now very timely, right? Reliable transfer, solving some issues like two large map registers. Yeah, I'm gonna ask you to pass the slide if that's fine. So next. Okay. Yeah, this is again trying to summarize or address some changes that have happened on the draft. Well, I mean, not on the draft, but in the mailing list that we have discussed since last ITF. Mainly these 2 points. That is, if an ETR supports reliable transfer, how does it know that the map server supports it too, so it can switch to reliable transfer? And then the question about what about other transfer protocols that are not just TCP and QUIC being the main example. So next. So the problem of an ETR that wants to use reliable transfer but doesn't know if the map server supports it, right? So by default, the ATR is going to always start with UDP map registers. That is what the protocol specifies. And at some point, it needs to do something, right? So it can switch to reliable transport if the map server supports it too. So how can we deal with this? Next. And I think this is what was discussed as part of the the follow-up from last meeting. That is, okay, we have some bits available on the map register message, so we could potentially use one to signal that the ETR wants to establish a reliable transport with the map server, a reliable transport session with the map server. So this is the classical discussion that we have had in multiple times in the working group. That is, we set up a new bit to 1 if the and we're going to see the bits in the next couple of slides. We set the new bit to 1 if the map server supports reliable transport. It's going to reply with the equivalent bit in the map notify set to 1 as well. If it doesn't support reliable transport, or the map server is a null one that or sorry, if it supports reliable transport but it doesn't want to enable, or if the map server is a null one that doesn't support reliable transport, then the map notify is going to come back with the bit to 0. So that way the ETR knows if it can or cannot establish a reliable transfer session with the map server. So next. So this is showing the possible location of the reliable transport bit on the map register, which seems straightforward. I think the next slide. I think the map notify one may be more interesting because one question for the working group is where do we put the bit on the map notify? So this slide is showing the bit in the same position as in the map register, so it's kind of mirroring the map register message, but we don't need to put it there. I honestly don't have a strong opinion there. I don't know if anyone wants to comment on that, but this is something we need to decide where the bit goes. Next.
Did you take question now?
Oh yeah,
Dino
sure.
is,
Yeah. Oh, Dino's in the queue already. Okay, good.
Dino?
I think it should be that lowercase r bit in the map notify should be next to the record count field, because if you need to use more bits in the map notify, you want to keep the contiguous bits there. Say you need 10 bits, then you would have to split up that new field on either side of the R. So I'd make it right justified.
That's fine with me. Yeah, I don't know if anyone has any other opinion. So yeah, unless someone wants to do otherwise, we can put it close to the record count.
Okay, I guess you can continue.
Okay, the other point to discuss is quick support. I guess that there are 2 questions regarding quick, and I'm not a quick expert, so I may be missing some aspects here. But one point is which port are we gonna use for quick reliable transfer, right? For TCP reliable transfer is evident. We use 4342 in TCP, and that's fine. For quick, shall we reserve a different port? Shall we just use 4342 UDP with quick on top? Shall we use any ports that quick specify as default? To be honest, I don't have an answer for this one. Maybe let's chat with Dino before we move to the second
Okay,
part.
Dino?
Yeah, you can't use 4342 because then the list daemon in the implementation will receive quick encoded messages. And so it has to just use quick as it's defined today.
So what
It
is
would be a
uh-huh.
disaster if you use 4342, right?
How do you see this, Dino? Because for me right now it is an open question. Like, which port do we use?
Use the UDP port number that's assigned to quick in the standard.
I did a quick search on the. I didn't find it, but I may be missing it because I'm not quick expert. So is there? Do you know if there is a quick port on the quick standard?
Absolutely.
Okay, fair enough. Yeah.
Or it can't run over UDP, right?
So yeah, send it on the list maybe, or send it to the authors of the draft, and we can use that number. And I'm
You
fine
don't have to
with
specify it. Just like you're not specifying how to use, well, you're specifying how to use TCP because, let's see.
I mean,
If you want,
you need a port.
you don't send, an application doesn't send over UDP and then sends over quick. It interfaces with quick directly, right?
But on which port? That's the question. So for me, the question is which port number?
Oh, I see, because the reliable transport now for over TCP uses 4342.
TCP. That's correct.
Oh, I think this is another UDP port number then, right?
Yeah, that's what I'm trying to
Then
get
it,
at.
then
You
it,
know.
that doesn't make sense. I think we're missing something.
If I may
It's,
chime in, I think that there is a difference between the quick socket that you open and you decide a certain port number and what is going on the wire. On the wire, you will see quick with the port number, quick port number somehow. I'm not sure. I'm not an expert.
Yeah,
There's just a guess, but we need to clarify.
okay,
So this is
okay, so what number one should say, should we reserve quick port 4342?
But there is no such
Because
thing as
on the wire, you don't see two UDP headers in this message, correct?
so. If I mean, if you want to connect with Quicks on a specific port number, maybe this is doable. How it is done, I don't know. But
Yeah.
we should just look at the same technique,
Yeah.
I would say. But we need to check and discuss on the mailing
Right.
list.
But I
on
think
this
we should
topic.
make it consistent with TCP, right? Use the same
The-
control port number for that transport layer, so to speak.
So the substrate of Quick is UDP. As far as I know, they do upper things, but the baseline is UDP. So we
Yeah,
cannot use
but the application doesn't care about it. Just like the application doesn't care that Lisp can run over Lisp, the application that runs over TCP, doesn't care that TCP runs over IP. Just like it shouldn't care that Quick runs over UDP because it's a lower layer and it's modular and it doesn't need to know that information and shouldn't touch it because the one who's originating the UDP packet is the Quick protocol, not Lisp. Lisp just runs over a Quick socket, so to speak, right?
But there are the documents, the list documents today, they are very clear on which ports we should use for TCP or UDP, right? So at least daemon or Lisp control plane element is going to listen on those ports and be able to parse and understand the list messages, right?
Yes, agree. So what I'm trying to say is we say that Lisp runs over UDP port 4342, over TCP port 4342, and over Quick port 4342. That's all. So what confused me and what triggered the question that number one has UDP here? Okay.
So I think that we are, going to a more fundamental question, and I guess this may be a quick discussion. But so TCP and UDP, you identify those by the protocol identifier, right? Quick, as far as I know, and I may be completely wrong, it has no protocol identifier.
Yeah.
You have a UDP header, so that the protocol
With
identifier
a
is UDP.
reserved port number.
It's the port number, but
Exactly.
I don't think there's,
if you have
I don't
from
think
TCP
when you run
to
over
it's
quick,
gonna be
there's,
UDP port number, not
Yes,
quick
yes,
port number.
yes. So we I mean, we need to check how is done on. So
Yeah.
apparently nobody
Okay.
here is a quick expert.
Let's,
quick expert.
let's take the discussion.
I would say that we check and we discuss this on the mailing list.
Fair enough.
This
Fair enough. Okay.
specific point.
Let's do that.
Sounds
Then,
good.
On the other side of the question is, if the ETR supports more than one reliable transport, typically TCP and quick, how does it know which one to use? The authors of the draft are leaning towards leaving this an implementation choice, so that if you support two, you could potentially probe for those two and pick whichever the member server replies, or whichever you like if it replies the two. Yeah, I don't know if anyone has any specific opinion on this.
I have a comment on this. I do agree this could be an implementation choice. The fact that you don't necessarily need to implement TCP, you don't need to use quick, as long as you have the basic, which is UDP.
And you should have the one.
Now, how do I signal that I can do more than UDP? This goes to the previous slide. If there is the reliable transport bit, it does not tell me whether I should use TCP or quick.
It does not. So probably you want to probe. Well,
or you use one bit per different transport. You have a T bit for the TCP, you have a Q bit for the quantum bit, no, the quick bit. It's a suggestion. I mean, this may be, I can send an email on the mailing list so that we discuss this point.
Yeah, that's fine. Yeah. I guess that we're not going to see a
reset that.
different transport protocols, right?
Well,
So,
we don't have zillions of transport protocol. I mean, so I don't think we're gonna waste so many bits on this.
In the VLAN case.
Because
okay, I think that's a good discussion for the mailing list.
Yeah. It's something to be pondered somehow.
Okay. Okay, that's it. My end. Oh no, there is a very final question. Sorry. Yeah. Working group adoption. Are we fine? Is there anyone that wants to say something before we call for a working group adoption of the document? It has been sitting as an individual draft for too long, I think, and it's becoming more and more relevant.
I have one final comments just on the content in general on the document. Is about the security part. I don't remember how is dealt with. I just came up to my mind. I mean, if we use TCP, we may want to use TLS in order to secure the communication. I mean, if we push this document forward, it's like LISP-SEC. I mean, there will be a thorough security review, so we have to make sure that it goes through. Doesn't mean that we need this to be done before adoption, to be clear. Okay, but I would put it as a action item that we check whatever should be done. I don't remember, to be honest.
That's a good point. Yeah.
So otherwise we got stuck somewhere else along the path. We know how it works. So
you're right that the security reviews may point to that. So
yeah.
Okay.
Good. As for the adoption, I don't think there is any issue. We can call for adoption here now and then check on the mailing list as usual.
Okay.
So we'll try to use the amazing tool that that we have here to check for adoption. So if you agree that this document is worthwhile, should be adopted, we work and we solve all the issues that have been discussed right now, you go on the Meetico and you raise your hand. For people in the room and remotely. I will close it now, and we have a clear consensus. I mean, I'm not sure it was it to read it, but 90% or more of the people that participated in the poll raised their hand. So I guess at this stage we go for
We'll take a
adoption. We
poll.
check on the mailing list. And the next, we concluded this part.
Okay.
Quick question
So,
on the poll.
Dino,
That's
yes?
assuming, yeah, this is Dino. It assumes that if we go, the reliable transport document goes working group document, that the BIS documents don't reference it, or otherwise we have another dependency, correct?
Anyway, the BIS documents are already there and out. We fix any issue that is raised during the IETF review or the different area review or the ISG review, but there is no reference there.
There is no reference as far as I remember.
Yeah,
Yeah.
and you're not proposing to put a reference there, right?
Yeah. No.
No.
Right,
no.
okay, good.
I don't
Just
think
want
I
to
want
clarify.
Okay.
Okay. Thank you, Albert. So, Bernard. It's weird. I feel uncomfortable to read all the details. And it's not consensus, rough consensus. Anyway, sorry, Bernard, go ahead.
So thank you. My name is Bernard. First time at the IETF, and I'll give you a short update on the draft title LISP ground-based RFC about the mobility and multi-link solution for safety-critical communication in aviation. It's a specific use case for LISP in this domain. So next slide, please. And to sort structure, I want to give you an overview about the LISP scope in this specific solution and the concept and how we using LISP to provide multi-link usage and the local policy overwriting if you have multiple routing links to the aircraft. And I want to conclude with some standardization requests for this IETF group. So next slide, please. So the ground-based LISP scope, we are mainly working here for safety-critical communication in aviation, and the ground-based LISP solution is implementing one mobility and multi-link solution for this safety-critical communication aviation, and we're mainly standardizing this on ICAO. This system enables the aircraft and the ground applications and hosts to use multiple air-ground access networks during all phases of flight. It distributes all the relevant information to the mobility and multi-link decision elements, which I will just explain then in the next slide, on ground and in the airborne IPS system. So one specific protocol we're using for exchanging information between the aircraft and the ground, it's called the Air-Ground Mobility Interface Protocol. That's a domain-specific protocol, and we will only specify this in ICAO, and it's not in focus here in IETF, and we are not planning to standardize this here. And we are using LISP here mainly to distribute all the information from this ACME proxy to the that's located in the access networks to the ground border routers, which are LISP XDR routers, and this ground border routers are the multi-link policy enforcement points for the uplink traffic. I think this will be more clear in the next slide when you see the architecture. Thanks. Next slide, please. So here we see the reference topology. It's subdivided in 4 segments. On the left side, you see the aircraft segment where we have an 18 IPS system, and we have here a downlink decision and enforcement point, and the aircraft is typically connected to multiple, via different radio access technologies, to multiple so-called air-ground communication service providers. This could be either satellite providers like Inmarsat or Iridium, or terrestrial-based providers like VDL Mod2 the current existing one or the LDAC. So these are very domain-specific radio access technologies. You see here, the next segment is the air-ground access network segment, where we have this ACME, this domain-specific protocol endpoint on ground. The endpoint in the aircraft is sitting in the Ethernet IPS system. And with this domain-specific protocol, we're exchanging all the information to the ACME ground proxy, which then forwards this to the next segment, which is the LISP segment. And that's why it's called ground-based, since all the LISP elements are located here on ground. There's an alternative proposal where also LISP elements located in the aircraft. And finally, the last segment is then the operator and the user segments. That's mainly ANSPs, so air navigation service providers like FAA or NAT, or airlines like Lufthansa or British Airways and so on. You see here all the abbreviations. We are using one important I want to mention is the MMB, the mobile network prefix. So this is a unique, globally unique IP version 6 prefix administratively assigned to an aircraft, so which the aircraft is using for communication during all the phases of flight. And this is /60 IP version 6 prefix, which is used from the IP version 6 area that is ICAO asking from a big address space. So next slide, please. Thanks. So a few words about the concept. So typically the aircraft starts with attaching to one or more of these air-ground access networks, mainly by using specific radio access technology specific means. It needs typically to authenticate to the access network. And then the access network forwards typically that announces that this mobile network prefix is reachable over the specific air-ground access network.
Bernard, sorry, in remote they ask to you speak closer to the mic, because otherwise they don't hear you.
Sorry, yeah. So then the aircraft it advertises the reachability by sending the mobile network prefix to the access network, and for that it's using this already mentioned ACME protocol. In addition, via the ACME protocol, we also exchange information like the link status and some specific traffic scope. Traffic scope here summarized by a sub-MMP, so a subnetwork of the mobile network prefix. And with this, the aircraft is able to announce routing preferences to the ground for the uplink traffic, meaning which link the aircraft recommends for uplink traffic for a specific traffic scope. So what, in addition, as an extended ACME information, there is some need for sending 4D trajectories to the ground, meaning the current position of the aircraft with a timestamp. That's for some users needful to use this for a policy decision on the uplink traffic. And some users need also a digital signature from the aircraft so that they can verify the identity and the integrity of the information that is forwarded. So this information then is sent to the ACME ground proxy, and the ACME ground proxy, currently we're using a northbound interface to forwarding this and mapping this information to the LISP control plane, mapping the preferences to LISP priorities. And this can be used by the ground-ground router, so the LISP XDR on the other side, to getting all the preferences and can use this preference for uplink routing decisions. For that, we're using the pub/sub mechanism. That means the ground-ground router subscribes to the MMP to this mobile network prefix, and it should also automatically subscribe with this to all the sub prefixes. In this example, we have two sub prefixes, A1 and A2, and I think in the next slide I'm explaining how this will be used. So next slide, please. So this is the multi-link usage. That means the preferences are sent down, and in this example, the aircraft sending a preference for the subnetwork A1 should be using the upper, the lower, the green one, the lower access network, and the sub prefix A2 should use the upper access network. And the decision point is the ground router. So it receives all the preferences, the mappings from the EID, so the mobile network prefix, and all the sub MMPs, the sub networks at the cache, in the cache of the ground router, and it using this to make the decision that the A1 traffic should be forwarded over the air ground access B, and the A2 traffic should be forwarded over the access network A. So that's mainly the multi-link that we how we're using a Lisp for a multi-link scenario. And so the next slide.
You have 3 minutes left, depending how you want to deal.
Thank you. So the uplink local policy is a use case I mentioned already. There are some users, they're using this only as a recommendation and to want to use additional information to override this. That means in that example, the local policy overwriting the A2 traffic, it should also go over the access network. So that means we need for this a policy decision point, which is located somewhere in the ATSO domain, and with this it reads out the preferences coming from the aircraft and is able to override this by the local policies. And for that information, doing so, we need some additional information that just results in the last slide. It's the next one, thank you. So this is what we are requesting from our support from the IETF, from the Lisp working group. The most important point is that we need in our domain standards for the Lisp control and data plane protocol. So the lack of these standards is currently the major risk for our ground-based Lisp solution. So that's an absolute must. So the RC 6830 and 6833 should go on the standard track. Without that, it's very difficult for us to use this. The pub/sub, publish subscribe functionality for Lisp. We would ask if you can move this from the experimental to the standard track. In addition, because we are using the pub/sub functionality for the mobility. In addition, we're asking for some additional clarifications and functions, like a selective subscription operation and what happens after deregistration, explicit selective unsubscription, and so on. So a few items we would like to have some clarifications and some discussions on that. We're asking for a network mobility support. So that means there is perhaps a flag that shows that this is a mobile network, and we could automatically remove all longer sub-prefixes. As you have seen, we're using sub-prefixes for traffic scoping, and this would help inside the mapping system to deregister or remove longer sub-prefixes. We want to include the network mobility feature to the draft IETF Lisp EAD mobility proposal. That's something that would help us to refer to this. And finally, something that would also help us to transport more information inside of Lisp. I mentioned the 4D trajectory snapshot. Digital signatures should be forwarded from the aircraft over the ACME to the ground router over the Lisp control plane. So if they're existing a mechanism to allowing that, that would help to use Lisp for that. Otherwise, we have to use an alternative solution for that. And we would also like to get an advice from you if we're either giving this in a specific change requests to the IETF, to the LISP IETF working group, or an alternative approach, we could create an experimental RFC for multi-link mobility that more or less describes the additional needs, and we referencing to all the other RFCs, generic pub sub and mobility RFCs. So whatever is the better process. Yeah.
Thank you.
That would help.
Albert, we have.
That concludes my presentation. Thank you.
Yeah, this is Albert Cabello. Thanks for your presentation. I think it's a very interesting use case. And also thanks for this slide. I think it's super clear what you're asking, and that's always something which is good. I'm curious about the first bullet point. I cannot comment. Maybe Luigi can comment. I think it is what it is. And the last one, I don't have any opinion either. But regarding the publish subscribe, could you elaborate a little bit further on the selective subscribe and explicit selective and subscription and wildcard? I don't understand that.
With selective subscribe means we subscribing only for one or for a number of specific multiple network prefix, for a number of specific EIDs, not for all.
Okay.
We want
So
to a list of EIDs we want to subscribe.
Okay, so not a prefix, but /32s inside that prefix.
Right, for example. Yeah, with the wildcard /32/40/42.
Okay. And then the digital signature, I don't understand it either.
Yeah, the digital signature is something that some users on ground would like to verify if there come preferences from the aircraft to the ground, how the uplink traffic should be sent. That this is forwarded over the ACME, over the LISP domain to the FAA, for example, to the ATSO domain, and they want to verify that this message comes originally from the aircraft. That means it should be digitally signed, and this should be forwarded over all the different protocols. Currently, we're doing this over the domain-specific ACME, but there is no way to forward this over LISP. It would help us if we have a specific part of LISP where we can user-specific data, forwarding user-specific data over the mapping system to all the XTRs.
Okay.
But that's just, yeah, it would make it simpler for us. Otherwise, we need an alternative protocol.
Yeah, I understand.
Yeah.
Thank you so much.
Alberto, you have one sentence and we move forward.
I think we support most of that. Let's discuss after the meeting.
Yep, thank you.
On the requirements, I would say you send an email to the mailing list with what is needed for you so that the discussion takes place there as well. Sharon.
Okay, thanks.
Thank you.
Okay, so the main purpose of this discussion now is there is no change to the RFC draft list next network hexagons. It's in the Alvaro queue, but there is a lot of progress in the industry, which I want to update you and experience we're getting by deploying with multiple carriers in Japan, in the US, with AWS wavelength. So basically,
sorry.
This thing doesn't, the listener is not something on its own. It fits to industry consortium work in the auto edge industry, which aims to unify what is termed V2V or vehicle to vehicle architecture, where vehicles tell each other about immediate problems, which doesn't work, and V2C, which is an aggregation into the cloud by all vehicles overnight, takes a few days. So we are able to unify with the consortium work the immediacy and programmability, the immediacy of V2V, the programmability of vehicle to cloud, but eliminate the interoperability impossibility of V2V. Every car gets multiple points of view for the same things from beyond line of sight, which is a big problem, and the lag of vehicle to cloud using one architecture. The question is why.
Sharon, you need to stay close to the mic. We can't hear you.
Yeah.
You need to stay at the mic.
Sorry, Joe. The question is, was over lunch, so why do we tie this whole structure with application routing and not with Kafka and database queues and all these mechanisms? And let me try to clarify that. So try to do it as quickly as I can. So first of all, volume. If we are talking about a city of 1 million active vehicles, like Paris, LA, and I want to use 10% of the vehicles to sample what's going on for double parking, hazards, blockades, sudden stops, things like that. Then I'm talking about, in any given second, 10% of the vehicles are sampling. They're moving at 30 meters per second. They need 10 frames per second in order to capture a point of interest. That means 1 million frames per second for the city and half a terabit, okay? These have to be processed by GPUs. The best case for GPUs is 1,000 frames per second. That means I have to really distribute between multiple sites in the city. That's routing. That's not a Kafka job. And then I have to consolidate this amount of traffic in the city so I can upload just the exceptions and changes to the cloud using 1 gigabit links, okay? On the downstream, next slide. On the downstream, if I have 1 million vehicles that over the next second are going to be in 10 tires, depending on the traffic pattern, and I have 1,000 active events in the city of people unloading, loading, making offenses, jaywalking, affecting 100 tires each, that every second I have to calculate a join of 1 million vehicles times 1,000 events at 1 billion times 1,000 tires, that's 1 trillion. That's impossible to do. The only way to do it is using feeds which are already pre-joined, multicast feeds, single feed application multicast feeds that scales really well. All right? So that's why application routing. It relates to a lot of the discussions this IETF. What do we get? We get something like an air traffic control for the city. So just like in air defense, missile defense, I separate the space into zones so to know what's going on in real time. That's what I'm doing on the road using crowdsource. This is improving the driver experience, but really looking forward to the near future, that's the only way to scale AV density, not to get AVs into situations which are hard to get out of, because then I can gridlock the city when the number of AVs goes up, and also reduce the cost of an AV. I cannot have a $10,000 car with a $10,000 computer. So that's what we're after. Slide down. The way we do it is, you know that already from the draft. We use EID space to divide the earth, pre-divide the problem into EID in hexagons, and we use the crowd to post data and process them in the hexagon. So this is familiar. There is a nice animation here of a car driving. You can check it out offline. We cannot do it here. But the RTRs are steering the uploads to the hexagons, where all the uploads for a given location are being processed and consolidated. Sorry. Yeah. Next slide. That's the upstream. On the downstream, what you can see is once a detection, a change, an exception was detected, there is a notification from the EID to the RTR and to the RTR in the cloud. Replication is done by the RTR. This scales the multi-billion join. Next. This is a tried and KDDI, multiple providers. There's a lot of edge providers in the game right now. Also Amazon, but it's not the only game like in cloud. The OEMs have computational facilities in the city. Other companies, and this is a trial going on in Japan. There is a deployment in New York, and there's a big trial going on in Nevada with AWS. Next. Okay, so just to understand what does application routing solve here, LISP. So in a cloud situation, I load balance clients between servers, okay, because it's all shared storage. In an edge situation like this, I cannot load balance the clients. These clients have to be in this service. These clients have to be in this service because the service is the location, has to consolidate. So what I have to do is solve a bunch of issues using application routing. So I am, instead of balancing clients on services, I'm balancing services on servers. I'm moving servers around based on activity, okay? And that is solved by the Lisp interaction. I have a problem of geoprivacy. Associating with a service means that if I'm subscribed to a parking service, the parking service provider knows where I am all day long. That's impossible. When I'm driving between locations, I'm changing context. That's a DNS, multi-second break in the service. That's unacceptable. Lisp solves that. And if I'm changing carriers, I'm changing my identities, and that's unacceptable, and Lisp solves that. Next slide.
Sharon, we are out of time.
Okay. So just a few, 2 slides or 3 slides. So let's solve all these problems. Next. Okay. If I put Lisp in the Mac, then I have a terabit per second from the mobile core split into using Metro Ethernet to the local zones. I'm solving the capacity problem well. Next. I'm solving the queuing problem. If I have a queue per vehicle at 5 megabits per second, 10 microseconds, 10 milliseconds away, then I optimize the queuing from the uplink using RTRs. I cannot bring processing to the Mac. There's no space. And the RTR are able to solve that problem and the high availability problem. Next. And downstream, the join problem we talked about. Next. It's really important to understand that Lisp is just one piece of this industry specification, but it's the connector between AutoEdge and 3GPP. Why? Because 3GPP interface is to an application server. There is no application server for the distributed edge application. Application routing is the application server. Okay? That's it.
Okay, thank you very much, Sharon. I'm sorry, but we don't have time for questions. I thank everybody. I say goodbye. Take care. See you again in Philly, online, remote. We'll see. Okay.
You commented that is there anything that we can do now to try to push
I spoke with Alvaro a long time. Basically, he was stuck with other documents that apparently were very huge. So he promised me to start look at the list document. Yeah, what happens? He has to review the documents and then. Okay.